Yo. Section 5.4 on medians and altitudes of triangles. So we already found that the median is the point of central mass of a triangle. And remember what a median is. Right? A median is a segment that connects the opposite or the midpoint of a side of a triangle with the opposite vertex. Next, the midpoint to the opposite vertex. So, concurrency of medians in a triangle. They intersect 2/3 of the distance from each vertex to the midpoint of the opposite side. That's called the centroid. So our point of intersection, the centroid, is where the medians intersect, and they're 2/3 the distance from each vertex to the midpoint of the opposite side. So here in this triangle, I'm going to label this ABC. And we're going to put point E there. D goes to that midpoint. And then that midpoint, point F. Huh? The centroid, the point of concurrency of medians, we're going to label point P. So AP from this vertex to the centroid is 2/3 the length of the whole thing. PD would be 1/3. So that's the same for all medians. So there's 3 types of problems that you essentially have to do. What if we have the short side? What if we had DP equals 3? Could I find what PA is? It's twice. So since this is 1/3, this is 2/3 of the whole thing. If that's 3, this has to be 6, right? And then the whole thing has to equal 3 plus 6 or 9. Huh? That's one of the types of problems we'd have to do. The next one. What if I'm given the longer side? Let's say EC is 10. Right? So from the centroid to the vertex, that's the 2/3 part. So can I find this EP part? Sure, it's going to be exactly half of it, or 5. So I have my 1/3, 2/3 split. Right? So the length of the whole thing, therefore, would be 15. Okay? That's if I get the 2/3 part of the segment. And then the last one, the last type of problem would be, what if you're given the length of, say, the whole thing? What if you're given the length of the whole thing is 18? Can I find the length of the sections in between? Okay. So they have to be divided into 1/3 and 2/3. So 18 divided by 3, that's going to be 6 right there. And then twice 6 is 12. The whole thing adds to 18. So those are the 3 types of problems. If you get the short segment from the side to the centroid, or the long segment from the centroid to the vertex, or the entire segment, you can solve for all of those parts. Try to do example 1 on your own. All right, so we're given in this one that PT is 5. So this section right here, PT is 5. So I can find the length of the larger section by doubling that. So RP is going to be 10. And then the length of the whole section, we're going to add those together. So RT is going to be 15. Those types of problems fairly easy. Right. Our last point of concurrency is the orthocenter. And the orthocenter is the point of concurrency of the altitudes of a triangle. Altitudes, hopefully, we've heard of before. That's how we measure the height of a triangle when we're trying to find area. Right? So altitude comes off perpendicular from a side to the opposite vertex. Altitudes can be outside of a triangle, as is the case with an obtuse triangle. So in an acute triangle, our orthocenter is inside the triangle. On a right triangle, the orthocenter is at the vertex of the right angle. Notice our altitudes in the right triangle are just the legs of the triangle, so the intersection is where that right angle is. And in an obtuse triangle, the orthocenter is outside the triangle. All right, so let's graph these 3 points in our example below and see if we can identify the orthocenter. So point A is at 1, 3. Point B at 2, 7. And point C is at 6, 3. We connect those points to form a triangle. And I want to figure out where the orthocenter is. So what I need to do is come off perpendicular from the side to the opposite vertex. So it's fairly easy to do with horizontal or vertical lines. Okay? My altitude here, right, I'm going to come off point B, perpendicular to the opposite side. There's an altitude right there. So this gives me the x-coordinate of my orthocenter has to be 2, right? It has to lie on that line. Now I just need to figure out where the other altitudes would intersect that out. So it comes off perpendicular to the side. So I'm going to calculate the slope of this guy. So I go up 1, 2, 3, 4 over 1. So the slope is 4. What's the slope of a line perpendicular to that? -1/4. Very good. So I'm going to come off this opposite vertex at a point at a slope of -1/4. I'm going to go back 1, 2, 3, 4, up 1. There is another altitude. Notice they intersect right there. So my orthocenter is at point 2, 4. Okay? We can find the other altitude by either going back through there. So the other altitude is right there. Right? Coming perpendicular from this line to the opposite point. So this has a slope of -1/1, so -1. So coming off here, a slope of +1 gets me to right there. So my orthocenter right there at point 2, 4. All right, that wraps up all of our points of concurrency. So let's finish this list over here. And then you can jot that down maybe in the bottom, right underneath the graph in your note packet, so you have those all in one spot.
Yeah.